Hello students, good morning to you all. Today I am going to discuss one of the important manufacturing techniques, namely powder metallurgy. Powder metallurgy technique was evolved during manufacturing of filaments for electric bulbs using tungsten. In this session you are going to learn what is meant by powder metallurgy and its various applications. What are the different operations involved in the process and their description? What are the limitations of powder metallurgy technique? Regarding the definition point of view, powder metallurgy is the manufacturing technique in which required components are manufactured by using metal powders. There are different manufacturing techniques are available in real life. Those manufacturing techniques can be grouped as machining, casting, forming and joining. In machining, excess material is removed and required shape is obtained. In casting, liquid metal is poured in the mold to get required shape. Forming. In the forming, the material is deformed into the required shape by applying force. Joining. Welding and riveting comes under the category of joining methods. Consider the manufacturing method of filaments. Filaments are made up of tungsten. How the tungsten filament is made up of? The conventional techniques will fail in manufacturing the filament by using the tungsten material, because tungsten is very hard and brittle. It cannot be suitable for either machining, casting or forming. At this juncture, the new method was found. This is called as powder metallurgy technique. If you consider the manufacturing of tungsten filament, first of all, tungsten powder is formed. But from the tungsten powder, different shapes are obtained. If these shapes are compacts or worked at high temperatures, then the tungsten becomes ductile. So the same technique is named as powder metallurgy technique, and it is having lot of applications. So powder metallurgy, we will go through the different applications of powder metallurgy. So one, self lubricated bearings. These bearings need not be externally lubricated. These are used in fans. Tungsten filaments, as we discussed how these tungsten filaments are manufactured by using the powder metallurgy technique. And other application is impregnated cutting tools. And refractory bricks. We know the refractory bricks are used for furnace linings. The refractory bricks can only be manufactured by the powder metallurgy only. Carbide tools, they are very hard tools. Actually, the carbide tips are provided to the tools. So this providing carbide tip is possible in powder metallurgy technique only. Clutch facings and brake linings. The friction material is embedded to the metal, takes place in the clutch facings and brake linings. Not only these applications, if there is a metal to non-metal combination is required, then we have to go for the powder metallurgy technique only. And also in electrical applications we will come across heavy duty electric contacts. These heavy duty electric contacts are manufactured by the powder metallurgy technique. And also current collector brushes are also makes use of this technique. Permanent magnets, which are made up of alnico, that is aluminum, nickel and cobalt. These three metal powders are mixed to manufacture the permanent magnets. And another application is metal filters. So before going to the sequence of operations of powder metallurgy, just we think of the native application of brick making. In brick making, first of all, sand is collected. After sand collection, the collected sand is sized, and then the sized sand is mixed with water. Then the brick shape is formed by using a small wooden die, and then it is subject to heating. Of course, in brick making, heating takes place in open atmosphere because there is no chemical reaction between the sand and the atmosphere. But this may not be the case of manufacturing of powder metallurgy components in case of metals. So now this diagram shows the sequence of powder metallurgy process. One, blending of raw material powder and additives takes place. Again, there are number of methods are available for preparation of raw powders. And after blending with additives like volatilizing agents, lubricants are added to the metal powders, and the blending takes place. After blending, it is kept in a die and subjected to pressure to have the desired shape. After shape is obtained, this is not suitable for regular application because it is having less strength. This is called as green compact. So this green compact is to be resist the strength to meet the real applications. So for that, centering is to be carried out. Centering is nothing but heating the green compact in the controlled atmosphere, or we can say in protected atmospheres, because if the green compact is heated in open atmosphere, it is subjected to oxidation and metal oxides will form, which will reduce the strength of the green compact. So the green compact is heated under the controlled atmosphere. Generally, the centering temperature is less than the melting temperature of the raw metal powders. After centering, finishing operations are to be carried out. Finishing operations also called as supplemental operations. These supplemental operations includes repressing, resintering, infiltration, forging, extrusion, rolling, heat treatment and machining. Now the component is ready for real life application. We list out the powder metallurgy operations in sequence. 1. Preparation of metal powders. 2. Mixing. 3. Compacting. 4. Centering. 5. Supplemental operations. These are the sequence of operations to be followed to manufacture a component by using powder metallurgy technique. Now we discuss the preparation of metal powders. There are number of processes are available. One is sorting, electrolytic deposition, reduction of chemical compounds and atomization. So we will discuss what the atomization, how the metal powders are manufactured by the atomization. In the atomization process, the liquid metal is forced through a small orifice. Then compressed air is forced against the stream of liquid coming from the orifice. Then liquid metal is divided into small particles and gets solidified. I will explain you by diagrammatically how this atomization process takes place. You see, there is a furnace. In the furnace, molten metal is prepared. That molten metal is forced through a small nozzle. Against the nozzle, water under pressure is sprayed. Then the stream of liquid is divided into small particles and gets solidified and collected at the bottom. This is the atomization technique. And mechanical pulverization. There are a number of methods are available by this method. These are also called as particle reduction methods. In these particle reduction methods, A is roll crushing. In roll crushing, the liquid metal is the solid metal is sized by passing through the rolls, and there is a ball milling, a vibratory milling, attrition milling, rod milling, hammer milling, impact milling, and fluid energy milling. What happens in this particle reduction methods is the bigger size particles are reduced to smaller size particles. Shorting. It is the another method of manufacturing metal powder. This process consists of passing the molten metal through a screen and allowing the drops of molten metal from the screen into a water container. Then the solidified metal powder is collected and dried. You see how the shorting takes place. There is a liquid metal that is made to pass from the sieve and collected the water container. In the water container, the small liquid droplets get solidified. And another method of manufacturing metal powders is electrolytic deposition. This method is suitable only for the electroconductive materials only. In this process, suitable electrolyte is taken and current is made to pass through the electrolyte. Then positive metal ions are formed and deposited on the negative plate. The negative plate is taken out and the metal powder is scraped up from the plate and it is dried. How this electric deposition method takes place is explained by using the iron sulfate electrolyte. There are the series of anode plates are there, series of cathode plates are there, and these are kept in the sulfate electrolyte. When current is made to pass through the electrolyte, the positive metal ions will form. These positive metal ions will move to the cathode and leaves 2 electrons and become metal particle. After that, the cathode plates are taken out and metal powder is collected from the cathode plates. So another method of manufacturing the metal powders is reduction of chemical compounds. In the reduction of chemical compounds, metallic oxides are reduced with carbon monoxide or hydrogen. Then the metal is subsequently ground to required size. Now we see the relative applications of the metal powder preparation methods. Atomization. Atomization is suitable for low melting metals like tin, lead and zinc. Mechanical pulverization. Mechanical pulverization is suitable for brittle materials like antimony, magnesium. Electrolytic deposition. Electrolytic deposition method is suitable for electroconductive materials like copper, iron and silver. Reduction of chemical compounds. This method is suitable for nickel, cobalt, iron and other refractory materials. So another technique of or another step of powder metallurgy is mixing. The raw material powder is mixed with the suitable alloying powders, lubricants, volatilizing agents and bonding agents. This is done to get the desired properties in the final product. Another step in the powder metallurgy technique is compacting. There are a number of compacting methods are available. 1. Die compacting, 2. Extrusion, 3. Isostatic compacting, 4. Rolling, 5. Slip casting, 6. Gravity compacting, 7. Explosive compacting, 8. Centrifugal compacting. So we discuss each method in brief. Die compacting. In die compacting method, the die is filled with metal powder. Desired shape is obtained by applying pressure through a ram using hydraulic or mechanical press. You see diagrammatically how die compacting takes place. In the first step, the die is filled with the metal powder. So that stage is called as filling. You see there is a die and there is a lower punch. From top, the die cavity is filled with the metal powder. In the second step, pressing. By lifting the lower punch and moving down the upper punch, the metal powder is compressed to the shape. Third step, ejection. After compacting to the required shape, the green compact is ejected. So another compacting method is extrusion. In the extrusion method, the metal powder is filled in the extrusion container. Then the metal powder is forced to the die using ram. See how the extrusion takes place. This is a container is filled with metal powder. It is pressed by using the top ram and required shape is coming out from the die. This method is called as extrusion. And another compacting method is isostatic compacting. In isostatic compacting method, the metal powder is taken in the rubber mold. Then the rubber mold is kept in fluid in the pressure vessel. Desired shape is obtained by uniform fluid pressure in all directions. So you see diagrammatically how isostatic compacting takes place. Here this is the rubber mold. It is filled with the metal powder and is subjected to fluid pressure equally in all directions. And this is also another method, only in other directions only the raw material powder is compressed. And another technique of compacting is slip casting. In the slip casting method, the required shape is obtained by keeping the slurry of metal powder in the mold made up of fluid absorbing material. Generally, this method is suitable for the thin products. Gravity compacting. In the gravity compacting, the die is filled with metal powder under gravity and required shape is obtained. Explosive compacting. In explosive compacting method, the metal powder is pressed in a closed die by using pressure developed by the spark discharge. Centrifugal compacting. In centrifugal compacting method, the die cavity is filled with metal powder. The metal powder is compacted to the required shape by subjecting the die to the centrifugal force. Sintering. The next step of the powder metallurgy technique is sintering. Sintering is done to give the sufficient strength to the green compact. The sintering process involves heating the green compact in the controlled atmosphere to get bond between the solid particles. And also the sintering mechanism involves of diffusion of atoms where intimate contact between adjacent particles leading to development of grain boundaries. Now we see how the sintering is affected by the important variables like atmosphere, temperature and time. As time increases, the ductility also increases. As time increases, strength also increases, and also as time increases, density also increases. And also the sintering depends on the sintering temperature also. Each material having its own sintering temperature. If you see here, it is a green compact. There is only metal particles are adjacent to each other. During sintering, what happens is initially neck formation along the adjoining edge takes place. After neck formation, the pore size is reduced, and after that finally grain boundaries are formed and the component is said to be fully sintered. Sintering is carried out in a continuous belt furnace. So this is the continuous belt furnace. In this, number of components to be sintered are kept. Here this diagram shows the how the grain boundaries are developed. The developing of grain boundary takes place simply by diffusion of the metal atoms along the adjacent edges. Now we see the sintering temperature and times of different metals. As we discussed, sintering is affected by sintering temperature and as well as time. For aluminum and its alloys, the sintering temperature lies between 370 to 520 degrees centigrade. The sintering time is approximately 24 hours. In case of copper and its alloys like brass and bronze, the sintering temperature lies between 700 to 900 degrees centigrade and the sintering time is nearly 30 minutes. In case of iron and steels, the sintering temperature lies between 1025 to 1180 degrees centigrade and the sintering time is 20 to 40 minutes. In case of tungsten carbide, the sintering temperature is 1480 degrees centigrade and the sintering time is 20 to 40 minutes. These are the some of the sintering temperature and times of different metals. And final operation in the powder metallurgy technique is supplemental operations are also called as secondary operations. The secondary operations namely coining, infiltration, impregnation, machining, surface coating and heat treatment. We discuss each secondary operation in detail. 1. Coining. Coining is nothing but repressing the sintered component to increase strength. Infiltration. It is nothing but filling the pores of sintered product with molten metal to improve properties. And then impregnation. Impregnation is nothing but filling of lubricants to get self-lubricating properties, whereas which are used in the self-lubricating bearings. Surface coating. Surface coating is nothing but coating the component to get corrosion resistance as well as better appearance. Heat treatment. The number of heat treatment techniques are available which are useful to improve mechanical properties in the sintered product. There are other influencing factors in the final product of powder metallurgy is the characteristics of metal powders. We consider these are the characteristics of metal powders like particle size, particle shape, apparent density, flowability, green strength and centerability. So, particle size, how it affects, we will see. Size, it controls the porosity, compressibility and amount of shrinkage. Shape, generally conical particle have excellent centering properties, whereas regular shaped particles have superior mechanical properties. Apparent density, it is the ability of the loosely heaped particles to fill the given die cavity. How it affects on the final product is the low apparent density requires long compression stroke during compacting, whereas increased apparent density decreases the shrinkage of the compact. Green strength, it is the strength of the component after compacting for handling. Another characteristics of metal powder is centerability. It is the ability of the particles to bind together without forming surface films. If surface film is formed, the strength of the component will be lost. Flowability, it is the ability of the metal powder to fill the die cavity. The powder metallurgy technique having its own limitations. One is difficulty to produce intricate shapes, because the metal powders will not have that much flowability when compared to the casting operation. So, it is very difficult to produce intricate shapes by the powder metallurgy technique. And another limitation is high tooling and equipment costs. In powder metallurgy technique, it requires compacting methods, equipments and centering equipments and for tooling and equipment for secondary operations. So, it involves high tooling and equipment costs. And third limitation is it is not suitable for components having severe load conditions. These powder metallurgy components are only suitable for moderate load applications, because these products manufactured by the powder metallurgy technique have less strength. The last limitation is the metal powders are hazardous. Now, I would like to recapitulate on the topic as we discussed. Dear students, in this session we learned the meaning of powder metallurgy and its various applications. We learned the sequence of operations involved in powder metallurgy, like preparation of metal powders, mixing, compacting, centering and supplemental operations. We understood the various metal powder techniques, compacting methods and centering mechanism. We also learned the limitations of powder metallurgy technique. Thank you.
Further clarification, contact the Additional Secretary, State Board of Technical Education and Training, 7th floor, BRKR Bhavan, Tank Bund Road, Hyderabad 500063. Fax 040-322-0546.